Alright, Geometry, Unit 4, Exam Review, last page, page 3, number 12. In the figure below, A and B are symmetry lines. If XZ is 27, and let's find XZ. Here's XZ. A diagonal is 27. What other segment is also 27? Well, you know diagonals are equal, so that would be WY. This segment right here is the same. If XM is 3, find WZ. Well, if XM is 3, that means that MY is 3, so XY is 6, because this is a perpendicular bisector. And if XY is 6, that means that WZ is also 6. So the answer for part B is 6. And finally, my overall rectangle here has blank fold rotational symmetry. Remember, rotational symmetry is how you can turn this so it lands right on top of itself. And it's hard to visualize with this, but take my paper for example. It's also a, well, take this note card. It's also a rectangle. So if I label this X, Y, W, Z, how many times can I fold it and make it the same before X, Y, W, and Z all land right back where they are? Okay, so I'm folding. Oh, well, there's one way. Okay, it's upside down, but it looks the same as it was originally. And then, so that's one fold, and then still not the same, still not the same, still not the same, still not the same, still not the same. Hey, there's two folds. Okay, so a rectangle has two-fold rotational symmetry. Hopefully that made sense to you. If it didn't, ask your teacher, and we can explain it further on the whiteboard. Okay, next one we're going on to a kite. You're given some information up here. We know that EK is 14, that's given. First thing we want is IK. Well, given a kite, those are the same, so that's 14. We want EXT. EXT is this angle right here, and just like a rhombus, a kite, the diagonals meet at a 90-degree angle, so that is a 90-degree angle there at EXT. I think I said EK, I meant EXT. At XET, again, if you're not sure on these three-letter angles, X, E, T, that's this angle right here. Just focus on this triangle you've got right here. Okay, you've got a 90-degree angle in it. You want this angle, and I'm betting they gave me ETX. Let's see. Oh, there it is. ETX 19 degrees. So, to figure out the angle XET, we're going to do 180 minus 90 minus 19. And we'll find that this is a 71-degree angle right here. And finally, EKI. EKI is this whole angle right about there. We know that EKT, which is half of this angle, is 40 degrees. So if this is 40, this has to be the same because there's symmetry in a kite. So the answer there is 80 degrees. For number 14, each symmetry line of a square is a perpendicular bisector of the side of a square. Well, that's false. That is false, folks. And the reason for that, quite simply, try to draw my best square here. You have 4 symmetry lines in a square. Yeah, you do have 2 of them that are perpendicular bisectors, but you also have 2 that are angle bisectors. And that's not a great representation, but hopefully you see what I'm talking about. 15, name the quadrilateral below. Be as specific as possible. This quadrilateral has 2 sets of consecutive sides that are equal, meaning that it has 2 sets of sides that are equal and touching. So this is a kite, by definition. Every rhombus is a trapezoid, is our next one. And this is a tricky thing. Best way I can, well, there's 2 ways of going about this. You can say, well, a rhombus means that it has 4 pairs of equal sides, or I'm sorry, all 4 sides are equal. Is it a trapezoid? Does that mean it has at least 1 pair of parallel sides? Well, yeah, because they're equal, you do. You have 2 pairs of parallel sides. So the answer is true. Another way of going back and figuring this out is remember your quadrilateral hierarchy, and I forgot a line on this, actually. If you can think of this as is moving up, okay? It only works going up. But a rhombus is a parallelogram, is a trapezoid, so a rhombus is a trapezoid. That is true. And then finally, for 17, every quadrilateral is a parallelogram. Think about that for a second. Is every quadrilateral a parallelogram? No. lots of quadrilaterals that aren't parallelograms, so that's false. Every parallelogram is a quadrilateral, though. Last one, refer to this figure below. If QU, which is a diagonal, is 12, and UA is 8, and XU is 9, find as many other lengths as you can. It's a parallelogram. So first of all, opposite sides are congruent. QD also equals 8. Okay? If I know UA, I'm sorry, I knew that. If I know QU is 12, then I know that AD is 12. So say that, AD is 12. You know those sides. And then finally, if I know XU is 9, then I also know XD is 9, because these bisect each other. They're not perpendicular, but they do bisect. So XD is 9. And if XD is 9 and XU is 9, then DU or UD is 18. So we'll say DU is 18. That's all you can figure out on that, which is quite a bit, actually. That is the review.